Alright, let's have a look at a tech-free application of using the normal distribution, and you'll see why you need to know those values for your 68, 95, 99.7%. Okay, so it says the heights of the women in a particular town are normally distributed. They're telling you they're normally distributed with a mean of 165 centimeters and a standard deviation of 9 centimeters. And with that, they go straight into what is the approximate probability that a woman chosen at random has a height that is between 156 and 174. Okay, so we need to set up the question first. So we're going to say, let X be the height of the woman in town. Now they've told us that it's normal, so we can say that means that X can be approximated by a normal distribution in mu and sigma squared. So X can be approximated by a normal with 165 centimeters. And be careful, they've given you the standard deviation and sigma squared, that's our variance, 9 squared. Okay. Now, what we need to realize is if mu is 165, then mu minus sigma, or one standard deviation down, is 174. Sorry, mu plus sigma is 174, and mu minus sigma is 156 centimeters. All right. So in that question, they're saying between 156 and 174. What they're actually saying is within one standard deviation of the mean. So what we're going to say is, therefore, the range is one standard deviation from the mean. And because we know that approximately 68% of all values will fall within that, we can say, therefore, the probability of X falling between 156 and 174 is approximately 0.68. All right, B. What is the approximate probability that a woman chosen at random is taller than 174? Okay, let's draw ourselves a little normal distribution over here. And with these questions, diagrams are your best friend because it gives your teacher an idea that you know what you're doing. It's a good communication tool. So that's what you want to do. Okay, so we know our mean is 165, and we know it's normally distributed, so we have a beautiful bell curve that looks symmetrical, and we know that one standard deviation from the mean is 156 and 174, so we know that that whole area there is 0.68, and we're interested in more than 74. That's X. So this is actually the area that we're interested in. Now, this is all based on symmetry. All right, so notice that this equals that, and the sum of the whole lot, remember it's a probability density function, so it means our sum of our probabilities are equal to 1. So we can say, if we know that the probability of X falling between 156 and 174 is approximately 0.68, then we know that our probability of X being less than 156 in union with our probability of X being greater than 174 must be equal to 1 minus 0.68. So that's approximately, isn't it? And that's about 32% or 0.32. But this thing is symmetrical, and we're only interested in the top half, okay? So the normal distribution is symmetrical So therefore my probability of x being less than 156 equals my probability of x being greater than 174. So that means it must be 0.32 over 2, which is 0.16. Okay, so therefore my probability of x being greater than 174 is approximately 0.16. All right, let's have a look at the next one. It says, what's the approximate percentage of the women in this town who are shorter than 147? Now we're no longer working with the 174, 156. So my immediate thought is, let's have a look if that's maybe 2 standard deviations away from the mean. Okay, so mu minus 2 sigma is going to be 165 minus 2 times 9. 147. And mu plus 2 sigma is going to be 165 plus 2 times 9. And that's 183 centimeters. Cool. So now we know that we're sitting within 2 standard deviations. So we know that our probability of the woman's heights falling within those 2 is about 95%. So this is within 2 standard deviations from the mean. So therefore my probability of x falling between 147 and 183 is approximately 0.95. Okay, now again, let's draw ourselves a little normal distribution. And again, we have 165 as our mean. And we're going to make this a pretty bell curve. That's our x, and we know that's 183, and that is 147. All right, so we know that 95%, or 0.95, falls within those values. And we are interested in this. What percentage falls below 147? Okay, now because we've already discussed the whole symmetry, we know that our probability of x being less than 147 in union with our probability of x being greater than 183 is approximately equal to 1 minus 0.95, so that's approximately equal to 0.05. And we also know that this is a symmetrical shape, so by symmetry, our probability of x being less than 147 equals our probability of x being greater than 183. So we have 0.05 over 2, and that's 0.025. Now they've actually asked for percentage, so we need to turn that into percentage. So therefore, the approximate percentage of women shorter than 147 centimeters is 2.5%.